In this video, I'll be giving you an introduction to the module known as PyMunk and showing you how we can use it to perform physics simulations. Now, this is a great module. It's really easy to use and you can do a ton of powerful stuff with it. And so I'm going to go through a few demos right now just to explain and show what the module is capable of. Then I will go through a tutorial where we actually build out a project using PyMunk. Anyways, let's have a look at this one right here. So I can actually use a camera in PyMunk and kind of move this around and view different objects. Obviously, some objects are falling off of the screen. I could say rotate the camera. Okay, that's the first demo I wanted to show you. These are all just demos that were provided by PyMunk. So let me walk through a bunch of them really quickly. Here's another one that's kind of like a flipper game. So I can spawn in balls and I can kind of flip them around. And the great thing here is that you don't have to understand or implement these physics on your own. You just place objects onto the screen and then control how you want to move them. And then all of the physics will be implemented for you. So you don't need to be great at physics to actually use this. Here's another demo. Let's have a look at what this one is. You can see that we can have kind of like a pivoting, I don't even know what you would call this, platform, rolling balls on here. Okay, pretty straightforward. Let's go to this one. This one is actually a playground, and what this lets me do is kind of create my own objects. So I can click here to create different objects. I can actually draw an object like this if I want to. Maybe I'll draw like a big square. Okay, that's this demo. Another one, we could make like a platformer game using this. So let's have a look here. You can see that I can move this thing around, jump up. I can actually double jump if I hit this twice. Again, just want to go through some quick demos and illustrate to you kind of the power of this module. Continuing, let's have a look at like a planet or satellite simulation. So let me run this one. Okay, we can see there's a bunch of satellites or planets that are revolving around the sun. Very nice. And then lastly, this is what we're actually going to build out. I think this is cooler than the demos that they had. Anyways, let's look at this. Okay, so here you can see that I have kind of this swinging pendulum. It's not really a pendulum. What I can do is place a ball, and I can actually launch the ball and destroy stuff. So this is what we're going to be building out. I'm going to teach you how to build this. It is not very complicated, again, because all of the physics will be done for us. Let's just hit this. Very nice. So with all of that said, hopefully you guys are excited. Now let's go ahead and get into the tutorial after a quick word from our sponsor. Before we dive in, I need to thank Altium Designer for sponsoring this video. Altium Designer is the world's most trusted PCB design system that enables engineers to effortlessly connect with every facet of the electronics design process. Altium Designer has used 35 years of innovation and development to create a truly unified design environment that makes it the most used PCB design solution on the market. Altium Designer provides an intuitive and powerful interface that lets you design PCBs rapidly while interacting and collaborating with your mechanical designers. The interface provides a photorealistic 3D environment, collaboration and synchronization with tools including SolidWorks, PTC Creo, and Autodesk Inventor, realistic rigid flex designs, multi-board assembly, and much more. Altium Designer is the most popular ECAD tool and electronics design software, and you can get started with it today for free by pressing the link in the description and registering for a free trial. Thanks again to Altium Designer for sponsoring this video, and now let's dive in. Alright, so let's start getting into this tutorial. I will mention that this is not designed for complete beginners. You do have to understand Python to be able to follow along with this, and if you don't know Python or you want to get better at programming, then you can check out my course, programmingexpert.io. You can use code TIM for a discount. I will leave that in the description. Anyways, as you saw, we are going to build the project where we can launch that ball around the screen, have it collide with different objects, and essentially just destroy whatever structures it is that we make. The way I'm coding this is going to be really easy for you to add other objects there, and you can kind of customize it however you like, but this will be a really good starter project for this module. Now, I do want to mention that I am not an absolute pro with this module, so there may be a few things that I explain that are slightly different than from the documentation. So if you really want to know everything that's possible with this module, then please do check out the documentation. I will leave that in the description. Okay, so the first thing we need to do here to get started is install the module. So open up your command prompt, open up your terminal if you're on Linux or Mac, and type in the following command, pip install, and then PyMunk. Okay, and then it's going to install it. And then if we want to be able to draw the simulation, we need to either use Pyglet or use Pygame. So I'm going to use Pygame because that's the one that I know best. So pip install Pygame. So Pygame will actually handle all of the graphics, and then all of the physics and simulator type stuff will be handled by PyMunk. Okay, Now, for some reason, those commands do not work. I will leave two videos on the screen and in the description that will show you how to fix this for Mac and for Windows. But you can try the command pip3 install Pygame and PyMunk, and you can also try this command. This one works for a lot of people: python-m pip install or python3-m pip install. Okay, at this point, I'm going to assume you have those modules installed. Now we are going to import them. So I've just opened up a file here in a Sublime Text. Feel free to open this wherever you'd like. Just call it tutorial.py. Doesn't really matter where you code this. And I'm going to say import Pygame. I'm going to say import and then PyMunk. And then I'm going to import, we want the math module. And I'm going to import PyMunk dot, and then this is going to be, I think it is Pygame underscore util. Let me have a look here at my cheat sheet. Yes, it is. So the reason we need this is because we want to set PyMunk up to use Pygame to draw. So that's what this import is going to be for here. Okay, now that we have that, I'm going to say pygame.init just to initialize it. And the first thing I want to do is set up a Pygame window that I'm going to draw all of the simulation stuff onto. So I'm just going to say width height is equal to, and I'm going to make mine 1000 width and 800 height. Now I have a large display, so I'll be able to see this. For some of you, it might be a little bit too big, so you can adjust these numbers to be whatever you want. And then I'm going to say my window is equal to Pygame dot display dot set underscore mode. And then inside of a tuple here, I need to pass the width and the height. Okay, so now we have a Pygame window. Now that we have the Pygame window, I just want to set up what's known as our main event loop, which is just going to display the Pygame window, and we're going to use PyMunk to actually render all of our stuff. So I'll show you how it works, but just bear with me for kind of the setup steps here in our code. So I'm going to make a function. I'm going to call this run. And inside of here, I'm going to take a window, I'm going to take a width, and I'm going to take a height. Now I'm going to make a variable. I'm going to say run is equal to true, and I'm going to make something called a clock. And what a clock is going to do is make it so that our main game loop is going to run at a certain speed. We'll see this in 1 second, but for now I'm going to say pygame.time.clock. And then I'm going to put a while loop here, and I'm going to say while, and then the variable run. So while that variable is true, we're going to do this. And inside of here, I'm going to say clock.tick, and I'm going to make another variable here called FPS, and I'm going to make this equal to 60. And then inside of here, I'm going to say clock.tick, and then FPS. So what this does is make it so this while loop here can run a maximum of 60 frames per second. So that's what the clock is doing, just regulating the speed so it's not going to run variably based on the other things on your computer and the speed of your processing cores. So if I didn't have this clock.tick here, then your simulation would be a very different speed than my simulation because it would depend on the speed of the processor and how quickly this while loop could be ran by your computer. All right, so now that we have this, I'm just going to set up an event checking loop. Now, what this is going to do is just loop through all of the events that are occurring in our Pygame or in our PyMunk simulation and essentially allow us to close the window when we hit the X button. So you'll see what I mean in a second, but I'm going to say for event in Pygame, and then this will be .event.get. I'm going to say if event.type is equal to Pygame dot, and then in all capitals quit, what I'm going to do is say run is equal to false. And then I'm going to break out of this while loop, or break out of this for loop, sorry. And what this will do is make it so we're no longer going to run the while loop. So essentially, we're looping through all of the events that are occurring in Pygame. So this will give us any mouse button presses, any keyboard presses, when we move the mouse, all of that type of stuff, as well as if we hit the quit button on our window. If we do that, we want to quit the game. So we're going to say run equals false, and then break. And then down here outside of the while loop, I'm just going to say pygame.quit. And what this will do is just quit Pygame for us. Okay, now I want to call this run function. We need to add a few more things to it, but for now I'm going to say if __name is equal to __main __. Then I want to call run, and I'm going to pass the window, the width, and the height to this function. Okay. So just a few more things here for the setup before I can actually start running the application and talking more about PyMunk. Now I want to make a PyMunk space. So with PyMunk, we have this thing called space. So what I can do is say space is equal to PyMunk.space. And the space is where we're going to put all of our objects. So what's going to happen is we're going to draw whatever's in this space. We can have multiple spaces, but in this case, we're just going to have one space. we place all of our different PyMunk objects, so rectangles, circles, polygons, whatever, different points that we have, the ball that's going to be moving around the screen, all of those go in the space. Then PyMunk will do a simulation within the space between all of the different objects. It will handle the collision of the objects for us. It will handle the objects moving around the screen. It will handle applying force to the objects and gravity and all of that type of stuff, so we don't have to do any of that, which is really nice. Okay, so then we're going to say space dot gravity, and this is going to be equal to a tuple, and we have to give a gravity for both the x direction and the y direction. So let's say we wanted to simulate being on Mars or something, or being on a really weird planet. I don't know if any planets have a gravity that is going in the x direction, but you know what I mean. I could set the gravity to be whatever I want, and we would be pushed either, in an x direction or y direction based on the acceleration that I put here. So what I'm going to do is put 0 and then negative 981. Now, I could do 9.81, but that's going to be really slow for my simulation. So when I do negative 981, this is just simulating gravity, right? Now, as you're going to see here in this simulation, we don't have to do all completely real values, and all of the units that we pass to the simulation are going to be completely up to us. So PyMunk is a unitless module or unitless library, and what that means is that we essentially decide what all of the units are going to be, as opposed to passing grams or kilograms or meters per second or meters per second squared or whatever the different physics units would be. We just come up with whatever we want, and we just pass the value to PyMunk. So here I'm passing 981. You can interpret that however you want, but that's going to be my gravity. And I actually want to make this positive because in Pygame, as we go down the screen, the y increases, and so I want my gravity to pull me down as opposed to moving me up, which would be what I get if I have negative 981. I'll continue to explain all the position and coordinates later on, but that is the gravity. So now that we have this, what I need to do is set up some drawing options for my space. So by default, the simulation here in PyMunk, it doesn't draw anything. It just does the simulation and then allows us to get the information about different bodies or different objects that we have. So you don't always want to draw it, right? But sometimes in our case, we do want to draw it. So I need to set up my draw options. So I'm going to say draw options is equal to, and then this is going to be PyMunk dot, and then Pygame underscore util dot, and then draw, and then options like that. And what I need to pass here is the window of Pygame that I want to use to draw my simulation onto. So I'm going to say my draw options equal to PyMunk.PygameUtil.draw options, and then I pass the window, and that's now where my simulation is going to be drawn. However, it's not drawn unless I manually draw it. So what I'm going to do is make a draw function here. I'm going to say define draw. This is going to take in my space, and it's going to take in my window. And the first thing I'm going to do is I'm going to clear my window. And the way I clear that is just by drawing a color onto the screen and filling the entire screen with it. So I'm going to say window.fill. I'm going to fill this with white. And then on the next line, I'm going to say space dot, and this is going to be debug underscore draw. And I'm going to pass to this actually, sorry, I need to pass my draw options. So I'll take in my space, I'll take in my window, and I will also take in my draw options like that. So we'll say draw options, okay? So this will draw the simulation for me. That's really all we need right now. And then if we wanted to draw anything else onto the window, we could do that inside of here, not from the space. We could just draw that using the regular Pygame draw methods if you're familiar with those. Okay, now that we have this though, I just need to call the draw function. So I'm going to say clock.tick FPS. And then right before I do that, I'm going to say draw. I'm going to pass my window. I'm going to pass my space, and then I want to pass my draw options, so I'll pass those like that. Nice. Okay, last thing I want to do here, after my draw, is I want to say space dot step, and I need to step this by a certain amount. Now, what the step is very similar to this clock.tick, but essentially it says how fast my simulation should go. So in this case, since I'm rendering 60 frames per second, and I want the unit that I pass here to be in seconds, I'm going to say, okay, well, I want to step this by 1/60th of a second every single time I run this while loop. So what I'm going to do is say dt, standing for delta time or difference in time, is going to be equal to 1 divided by the FPS. So whatever I set the FPS to, I want my displacement to be, or not displacement, difference in time, delta time, whatever, to be 1 over FPS. So I'm stepping every single loop, my simulation forward by 1 over the FPS, seconds, right? Hopefully that makes sense. Excuse me, just need to clear my throat there. Okay, so space.step, displacement time. I keep saying displacement time, delta time, and that will actually step the simulation forward. Now, I know we've just written a lot of code. We haven't tested anything yet. We also don't have any bodies on the screen, but let's just run the code and see if we're getting any errors. And then we'll continue and actually place a body into our space and watch how gravity pulls it downwards. So let's run this. And we got an issue. It says space object has no attribute fill. Okay, my apologies. So the issue here is we have this draw function and we have space and window, but I passed window and space. So I need to pass this in the other way. Space window, just so my order is correct. Okay, let's rerun this. And what's going on here? Okay, so we don't get any errors, but notice here that I'm filling my screen with white, but we're not actually seeing that go on the screen. The reason for that is I haven't updated the display. So I'm going to say pygame.display.update. So now when I do this, we should see that we get a white screen. And we do. There we go. We have set up kind of the basics of our application. We now have stuff being drawn onto the screen, or at least we have a white background. Now we want to actually use PyMunk to add an object to the screen and then watch how gravity pulls it downwards. So let's make another function here. Let's say define, add, and let's just go with object for now. And let's take in space in here, and let's add an object to our screen and then watch it move around. So in PyMunk, we have what's known as a body. Now, a body is a rigid body from physics, if you're familiar with that. And we also have what's known as a polygon, or a kind of a shape. So we have a body and then we have a shape. Now, in PyMunk, what we do is we separate the collision and kind of the physics of an object from its representation on the screen. So we may have an image that we display, and that image will be linked to a specific body, but all of the calculations and computations that we're doing are related to the body. Now, I know this is a little bit confusing, but we have the image and we have the body. The image is attached to the body, but we do everything on the body. So that way the image that we show can be slightly different than what the actual body is. So if you're familiar with like FPS games or anything where there's a hitbox involved in it, that's kind of what the point of this is here. We have like the underlying hitbox, and then we have the image that we put on top of it. And so we'll make the underlying hitbox usually simpler, and then the image will be more complicated. So if you're familiar with, any video games, you've probably seen this before, where maybe you shoot someone, and if you shoot like on the very, very edge of the actual sprite that's being drawn on the screen, it doesn't say that it hit them because it didn't hit the underlying body or the underlying hitbox. So I just wanted to explain that before I start coding this out. But for now, let's create a body. So I'm going to say body is equal to, and then this is going to be PyMunk dot, and it's going to be body like this. And for our body, I don't need to pass anything inside of here. I just initialize a body, but what I will do is set its position. So I'm going to say the body dot position, and then I pass a tuple, which is the XY of the center of the body on the screen. So if I want the center of this body to be at, say, 300, 300, then I pass that. Now, as I said in Pygame, actually, let me run this here so I can explain this. The top left-hand corner, so 0, 0, is right here. So 0, 0 is the top left-hand corner, which means if I go to the right, my X is increasing. So over here would be the width and then 0. And then the bottom right-hand corner would be the width and the height. That would be the position. And then the middle of the screen will be width over 2, height over 2, as opposed to being 0, 0. I know many people are familiar with the middle of the screen being 0, 0. Not the case in Pygame. The top left is 0, 0. So that means when I'm drawing at 300, 300, I'll be drawing like kind of close to where my mouse is here. Yeah, that's where I'll be drawing. Okay, so we set the position to be 300, 300. Then what I need to do is actually have a shape that I'm going to draw with this body. And I need to attach this shape or this polygon to the body. So let's go here and say shape is equal to, and then this is going to be PyMunk dot, and then circle. And I want to pass to this a body as well as a radius. So let's actually change this function here. I'm going to change this to say create ball. Okay, we'll take in the space, we'll take in a radius, and we'll take in a mass for now. So the radius will be passed to this function, so we'll just use it here. And then once I've done this, what I want to do is set the mass of this object. Now we need to have the mass because we're going to be moving this on the screen, and well, to apply gravity to it, it needs some mass. So we'll set the mass equal to whatever mass it is that was sent in. And then if I want to change the color of this shape, I can say the shape.color is equal to, and then I have to pass an RGBA value. So that's red, green, blue, alpha. So for now, if I want the ball to be, say, red, I would do 255, 0, 0, and then 100. So the last argument here is between 0 and 100. It's the alpha or the opacity or transparency, whatever you want to call it, of this object. So if I made it 50, then it would be 50% transparent. When I make it 100, it's completely opaque, and so we can't see through it. Okay, so now that we have that, what I need to do lastly is say shape.add, and I need to add both the body as well as the shape to the simulation. So I'm going to say body and shape like that. And then what I can do here is I can simply return the shape. Okay, so I know I just went through a lot here. Again, all we're doing is we're creating a body. We're creating a shape that's going to be for that body. Then we're setting the mass, we are setting the color, and then I need to add both of these things into the PyMunk simulation so now they can be moved around. I can't just add the shape. If I were to do that, it's not going to work because what is it attached to? Well, what it's attached to isn't now in the simulation. However, I could add the body without adding the shape if I wanted to. Anyways, the point is I need to add both the body and the shape here to the simulation for this to work properly, and they'll be kind of attached to each other. Okay, so let's now run this. So what I want to do is say, let's go here, ball is equal to, and then this is going to be create ball, and I will say space, and then not the width and the height. I need to pass a mass as well as a radius, and I think the radius is first. So let's pass a radius of like 30 and a mass of say 10. Now again, treat these units as whatever you want. We could say this is like 10 kilograms, whatever. It doesn't really matter what unit we want to say it is. Okay, so now that we have that, it should just be added to the simulation, and we should see when we start drawing, it actually shows up on the screen. So let's run this, and notice that we have a ball, and it just instantly starts falling because of gravity, right? Awesome, that is what we wanted. Everything is working great. Okay, so now that we have created a ball, the next thing I want to do is create some boundaries on the screen so that the ball can't just fall through, right? Now, the thing here is that the objects that we currently have and that we place on the screen, they're going to have gravity applied to them because they're not static. They are dynamic objects, or they are dynamic bodies. So for these different bodies here, we have an option to either have a dynamic body or a static body. I think there's another option as well, but those are the two main ones. So now we want to create some static objects that are not going to move and just are going to be kind of walls and floors for the simulation. So then objects can't kind of fall through, right? So let's figure out how to do that now. Let's write a function. Let's say create and then boundaries. And inside of here, I'll just take space. I'm going to take the width and the height of the screen because I'll draw these dynamically based on what that width and height is. So I'm going to start by making a list here. I'm going to say rex or rectangle is equal to a list. And here I'm going to define all of the different rectangles that I want to draw onto the screen. And then we'll use a for loop to loop through all of them and draw them rather than writing out the draw command 4 times in a row, which would be a lot of unnecessary code. So for a rectangle in PyMunk, you simply need an X and Y position of the center of the rectangle, and then you need the width and the height of that rectangle. So I'm going to pass a list here. I'm going to put a list here. And then for the width and the height, again, this is the center of the rectangle. So the first one I'm going to do is going to be width over 2. And then this will actually be height minus, and then I'm going to make the height of my rectangle be 20 units. So I'm going to subtract 10 here to make sure that we are perfectly flush at the bottom of the screen. So then the next thing I'm going to pass is the size of the rectangle. So I want the size to be the entire width of the screen, and I want the height of the rectangle to be 20. So again, we want to pass the center of the rectangle. So if I want this to be directly in the middle of the screen, I pass width over 2 for the center of the rectangle. And then I want this to be right at the bottom of the screen, and I want to have a height of 20. So since I want it to have a height of 20, I pass height minus 1, because as we go down, we increase in Y. So we take the height, which will be 800. We subtract 10, so we're going to place this at 790, the middle of the rectangle, meaning that this 20 height right here will take up the entire bottom aspect of the screen. None of it will be off of the screen. Okay, so that's what we're going to have for the floor. Then we want to have the ceiling. So for the ceiling, this will be the same thing, except it's just going to be 10 for the Y. And actually, we don't need to change anything here. So we just change the Y, translate it all the way up on the screen. So now it's at 10 as opposed to height minus 10. Now that we have that, we want to have the walls. So let's copy this, and actually let's paste it twice. Now the walls will be slightly different. The first wall we're going to want to place at position 10, and then we're going to have this be at height over 2. Actually, I think that's correct. Yeah, height over 2. Then we're going to have the width be 20. And we're going to have the height be equal to height. And then for the next wall, this is going to be at height, or sorry, not height, width minus 10. And then this will be again height divided by 2, and then it will be 20 and height. Okay, so let's explain why I did this. So for the x coordinate, we want this to be to the furthest left possible. So we're going to put 10 because the width is 20. So that means the middle will have it perfectly lined up with the left-hand side of the screen. And then for the height of this, I need to pass the center of the rectangle for the height. So I'm passing height over 2. That's going to be perfectly in the middle of the screen. And then I want to have the width of 20 and the height of height. And then the same thing pretty much applies here with the width minus 10, like it did with our height minus 10. Okay, so now we have all of our rectangles, so we want to draw them. So I'm going to say 4, and then I'm going to say that this will be the position and the size in and then rex. And then that will give me each one of these elements as I loop through, okay? And I need to make a body as well as a shape for this body. So I'm going to say my body is equal to, and then this is going to be PyMunk dot, and what will we do here? This will be body, except this time I don't want the body to move, so I have to make it a static body. So I'm going to say my body type is equal to, and then this is going to be PyMunk dot, and then body dot, and then static like that. So that means it's not going to move. Now that I have that body, what I can do is put the position. So I'm going to say body dot, and then position is equal to my position, and then I want to make a rectangle that I'm actually going to show on the screen for this body. So the way I do that is I say my shape, or I could say my polygon or my rectangle or whatever I want to call it. Let's go with shape is going to be equal to PyMunk dot poly dot, and then I'm going to use this method here called create box. And what create box will do is it will take in the body that I want this to be associated with or attached to, as well as the size. Now, I will also mention here that you can make some more complicated objects where you define this body and then you have multiple shapes or multiple polygons that you put onto the same body. So just keep that in mind. You can do that if you want to. You can make some really cool and advanced shapes, and we'll look at that when we actually create kind of that pendulum that has the circle as well as that line segment that's attached to that, I don't even know what you would call it, like elastic or rope or whatever you want to say it is. Anyways, now that we've done that, all we actually need to do is just add this shape to our space. So we're going to say space.add, and we're going to add the body as well as the shape. Okay, there we go. All right, so now we have created the boundaries. Again, we make our body, we set the position of the body, then we make the shape. The shape is attached to the body. All right, so now that we've added this, we should be able to just call this function and then actually see all of our boundaries on the screen. So let's call this right after we make our ball. So let's say create and then boundaries like that. And what do I need to pass here? I need to pass the space and the width and the height. So let's pass space, width, and height. And let's run the code and see what we get. Okay, so notice now that my ball is going to stop because, well, it hit a floor, and these are all our static bodies that are sitting around that are not being affected by gravity. Now, just for experimental purposes here, let's see what happens if I remove the static type. So if I remove static here, I do need to add a mass either to the body or to the shape. So I'm going to say the shape.mass is equal to 10, just so I don't get a crash. But let's run this now. And you'll notice that all of these are going to fall, right? Because they are not static. So let's go back to static. I just wanted to prove to you this does indeed make it so they stay still. All right, so now that we've done that, let's run this one more time. And notice what happens when the ball hits the ground. It just stops completely. It doesn't bounce, it doesn't roll. Now, why is that happening? Well, the reason that's happening is because there's no elasticity between the ball and between the floor. So what I can actually do is add a property to both the ball as well as the floor called elasticity, and that in this context here is going to relate to how bouncy either of these surfaces are. So for my rectangles, I probably don't want them to be too bouncy, but I'm going to say shape.elasticity, and this will be equal to something like 0.4. And while I'm at it, I can add a friction. So I can add a friction like 0.4 or 0.5, and that's going to be the coefficient of friction between this and then anything else that hits it, although the other objects that hit this will have a friction as well. Again, please reference the documentation if you want to see exactly what all of these different properties mean and how they work. It is slightly confusing, and again, I'm not mastering this module. I'm just giving you a basic introduction. Okay, so now we have our elasticity and our friction. So I'm just going to go to my create ball, and I need to add the same properties here. But before we do that, we can test it and see what happens if we just add these two and don't change anything on the ball. So notice now nothing happens because if one has an elasticity but the other doesn't, it's just going to stay still. So we need to add elasticity on the ball as well. So I'm going to go here and say shape.elasticity is equal to, and then I want this to be pretty bouncy, so I'm going to go with 0.9. Now you can go higher than 1 if you want, but if you do that, you'll get some really weird results. And essentially, the higher the number you have here, the more elastic or the more bouncy it's going to be. So we have that for the ball elasticity, and we're going to have shape.friction, and let's just make this equal to 0.4. And again, higher number here is actually going to be the more friction, lower number, less friction that you have. Okay, let's run this and see what we get. And now notice that the ball actually bounces when it hits the floor. So that's what we wanted. Didn't bounce a ton, but if we were to increase the elasticity on both this shape here as well as this shape, then you would see that it would bounce more. Okay, so we now have a ball. We now have our boundaries. Now let's make it so we can shoot the ball around the screen. And then once we do that, we can add some obstacles to the screen or kind of structures that we can destroy, or we can, I guess, make them tumble over. And that will pretty much wrap up the simulation for now. Okay, so let's make it so we can shoot the ball. So first I will show you how we kind of apply force to an object. And then once you see how that works, it'll be pretty easy to actually set up kind of the angles and make it so based on how far our mouse is from the ball, that's the amount of power we get when we launch the ball. So I want to add an event here. So I'm going to say, let's go like this. If Pygame.event, or not Pygame.event, if event.type is equal to Pygame dot, and we're going to say mouse button down. So if you hit a mouse button, okay, mouse button down, then what we will do is, okay, what the heck? Sorry, I need to fix this mouse button down. Sorry about that. If you press a mouse button, then we will apply force to the object. So the way that we apply force is we first need the object. So in this case, we have a ball. So I'm going to say ball dot, and then body dot, and then this is going to be apply underscore force. I think it's actually going to be apply impulse at underscore local something. I got to look at what this method is because I forget exactly what it is. But it is apply impulse at local points. Okay. Apply impulse at local point. And then what we need to pass here is the amount of force that we want to apply. So I'm going to apply a force of 10,000 and then 0. And then I need to say where on the object I want to apply it. I want to apply it at the center, so I'm going to pass 0, 0. Now let's take a step back here just so we understand what all of these different aspects are. So first, we see from create ball, we are returning the shape. So notice we're not returning the body, we're returning the shape. Now the shape has an attribute on it called body. So I'm going to say ball.body to get access to the body because again, all of the physics stuff is happening with the body, not with the shape. So I need to apply the impulse. And what an impulse is essentially a very quick force being applied to an object at a certain location. So this is the force that I'm applying in the X direction. I'm applying no force in the Y direction. And then I'm applying this at 0, 0. Now when I apply that at 0, 0, it means the center of the ball. If I wanted to apply it slightly, I guess, to the left of the ball or not directly in the center, then I would change these different coordinates right here because I'm doing this at local point. Now, I also can apply an impulse just at any location in my space. Again, I'll point you to the documentation to see exactly how to do all of that stuff. But there's a bunch of functions here for applying forces to different objects. This is just the one we're going to use right now. Okay, so that's really all we need for now. I just want to see what happens when we click the mouse, essentially, with our ball on the screen, and if this force is going to be too little or too large. And what will affect this force here is going to be the mass of the ball. So where is our ball here? Well, our mass actually we created right here. So we have a mass of 10. If we increase this mass, it will decrease what the force is going to do to this object because we need more force to move a heavier object, right? Anyways, let's just run this and let's see what we get. Okay, and when I pressed the mouse button, it gave me an error. It said, body object has no attribute, apply impulse at local point. Well, we should spell impulse correctly. That will probably fix it, so impulse like that. Let's run the code. Let's click the mouse button, and then notice it kind of launches our ball around. It's applying the force at 0, 0, and the ball will actually spin. Nice. There you go. That is what happens when we apply our force. Okay, so now that we've seen how to apply the force to the ball, let's actually just make the force a little bit larger. So let's make this like 50,000, and let's see if we get any weird errors or not. Okay, actually that's working fine, and notice I actually went through the ceiling. So the reason that happened and why I wanted to show this to you is that if you apply, or if you have a velocity that's really high in your simulation, there's going to be a chance that between the two frames where your ball is moving, in this case because it's a ball, you don't actually end up finding a collision with an object because the ball moves way too quickly. So essentially the way collision's working is every single frame you're checking if it's hitting an object. Now, since the ball is going to be moving so quickly, what happens is it will start like maybe right close to the wall, and then the next frame it will already have moved outside of the wall, and so you won't have seen that it collided with something because in one frame it moved. Whereas if you have a less velocity, then you can actually check for a collision because you'll see that it actually goes inside of the wall. Then you can kind of pop it outside of the wall and make it bounce outwards, or make it bounce off the wall. Hopefully that makes a bit of sense, but I just wanted to show you if you have your velocities too high, which happens when we apply this much force, there's a probability that you could actually miss collision with an object, especially if that object is very thin. All right, so now that we've looked at that, I want to make it so we launch the ball at a specific angle based on where our mouse is relative to the ball. Same thing with the power that the ball gets. That's going to be relative to how far the mouse is away from the ball. So I want to write two functions up here that we're going to use in 1 second. The first function is going to be calculate distance. This is going to take in a 0.1 and a 0.2 and just return the absolute distance between these 2 points. So the way I do this is I can return the math.sqrt of, and then this is going to be P2 at, 1 minus, and then P1 at 1. Now these are going to be tuples of x, y positions, okay? We're going to raise this to the exponent 2, and then we're going to add this to the P1 of, the P2 of 0 minus the P1 of 0 to the exponent 2. Okay, so that will give us the absolute distance between 2 points. Then I want to do something that gives me the angle between 2 points. So I'm going to say define, calculate, and then angle. And this is going to be P1 and P2. And I'm going to return the math dot, then arctangent 2. And then I need to do P2 at 1 minus, this will be P1 at, and then 1. And then this is going to be P2 at 0 minus P2, or minus P1 at 0. Okay, so what arctangent 2 gives me is the angle in radians between these 2 points, assuming that point 2 is located at 0, 0. So if point 2 is 0, 0, then point 1 is anywhere around point 2, and it gives you the angle between 0, 0, which is point 2, and then the other point. Hopefully that's clear, but that's what arctangent 2 does, gives it to you in radians, which we'll use. So now that we have both of these things, what I want to do is draw a line between my mouse and the ball whenever it's on the screen, just so we can clearly see kind of what angle we're getting and the relative amount of power. We'll draw that line onto the screen, and then I will use the coordinates of the ball as well as the ending point of the line, which is just going to be our mouse, to determine the distance as well as to determine that angle. So what I want to do, and what you saw previously, is I want to make it so when you click on the screen, it spawns the ball wherever your mouse is. That way we know the position of the ball, and then we can use the position of the mouse and the ball to draw the line, so on and so forth. So the first thing I need to do here is I need to remove this ball equals create ball here, because I only want to do that when I click down on the mouse. So I'm going to make 2 variables here. The first variable is going to be pressed underscore pause, which for now is going to be equal to none. And I'm going to say ball, and this is going to be equal to none as well. Then in my pygame.mouseButtonDown, we'll comment this out for now, and we'll say if not ball. So if there's no ball currently on the screen, then we want to create the ball. So I'm going to say ball is equal to create ball, and yeah, that's fine for now. Now after I create the ball, I want to say the pressed underscore position is equal to, and this is going to be pygame.mouse.get underscore position. And actually, I need to use this when I create the ball because I want to place the ball at a certain position, right? So when I create the ball, I'll pass the space, I'll pass the radius, the mass, and then I will pass the position, which will just be equal to pressed underscore pause. So now I need to go here to when I'm making the ball. I'm going to take in a position. We're going to say body.position is equal to pause, and that will put it directly in the center of our mouse, which is what we want. Okay, so now what should happen is when we click the mouse button, it should create the ball, add that to the screen or add that to the space, and it should be exactly where our mouse is. Let's try this. Let's click, and there you go, it makes the ball. And then it's not going to let me make another ball And the reason it doesn't let me do that is because I have the ball variable defined. So this if statement is false, or the condition here is false. Okay, now that we've placed the ball though, I want after we've placed it to be able to launch the ball, and then additionally to be able to click again to delete the ball. So I'm going to say if pressed position. So if we have this variable here, so I'll say elif pressed position, then I want to launch the ball like that, okay? So if we have created the ball, then we can launch it. And then lastly, I'm going to say else. I want to say ball is equal to none. And then the press position is equal to none as well. So what happens now is if we don't have a ball, we press, it will create the ball. If we have the ball, so we have press position, then we will launch the ball at the angle between our mouse and the ball. We haven't done that yet, but that's what we'll do in a second. And then lastly, if we've just launched the ball, when we click again, it will delete the ball from the screen by removing ball and removing press pause. Now I also realize I have to do something here, space dot, and then remove. And I need to remove the ball as well as the ball dot body from the screen, okay? So when I do this, it should remove both of them for me from the space or from the screen. Okay, hopefully that makes sense. That's what we're doing here. Let's rerun and let's see what happens. Okay, I click. When I press, it launches. And when I press again, for some reason, it is not actually deleting the ball. Okay, the reason for this is that I need to say pressed position is equal to none inside of here, sorry, and then remove it from here because this was never going to be set to none. So I'm just constantly launching the ball. Now, after we launch it once, sets that equal to none. So then we're able to actually set ball equal to none and then remove it. And I can't set ball equal to none before I remove it. So we want to remove this before we do that. Okay, a few bugs, but that's fine. So let's rerun. Now let's see what we get. Launch, and then it removes it from the screen. Then I hit, okay, launch, removes from the screen, launch, removes from the screen. Nice, that is all working. Okay, now we just need to calculate those angles. So what I'm going to do here is write a variable above here, and I'm going to say line. Actually, I'm going to say if the ball is on the screen, then line is going to be equal to, and this is going to be the pressed position, as well as, and then our Pygame dot mouse dot get underscore pause, but I want to actually swap these around here. Okay. So I'm just putting the two coordinates I want to draw a line between. So the mouse position as well as the ball. And actually, no, I want it the other way. Sorry about that. This is the correct way I had it right the first time. And then before this, I'm going to say line is equal to none. Okay. Then what I want to do is pass this line to my draw function. So then inside of draw, we can draw the line onto the screen. So now let's go here to our draw and let's take an A line. And let's just go here and say if line, so if we have a line, so if it's not equal to none, then what I will do is pygame.draw.line. I want to draw this on my window. What color do I want to draw this? Let's just draw the line in black. And then we'll pass the position 1 and position 2 of the line. So this will be line 0 and line 1. To get the two different positions. Then I can pass the thickness of the line. Let's just go with the thickness of 3. Okay, that should draw the line for us. I also want to put this before I draw this, so it will be beneath my ball and beneath everything else. We'll see if we want to change that or not, but for now I want to draw it before this, so this gets drawn over top of it, so we'll have the line underneath the ball, not over top of it. Okay, now let's try this. And let's see. Okay, so we're getting an error here, and the issue is that I set the press position of the ball right when the ball spawns on the screen, but the ball's moving. So since the ball is moved, obviously now the position is different than it was before, but my line is working from a static position. So what I'm going to do is make it so that when I make my ball, it's not going to be moving, it's going to be static, but then as soon as I'm about to launch it, we will make it so it's no longer static, it's dynamic, and then it starts moving and we stop drawing the line. All right, that makes more sense to me. So body is equal to PyMunk.body, and then this is going to be body underscore type is equal to PyMunk.body.static. Okay, and then before we want to launch the ball, we need to make it dynamic. So what I can do here is say ball dot, and then this will be body dot body type is equal to, and then PyMunk.body dot, and then dynamic. That changes the type for us. And then here for my line, I'm going to say if ball and pressed position, because if I set the pressed position equal to none, meaning I've just launched the ball, I don't want to be drawing the line between my mouse and the ball because I can't launch it again. I need to remove it and then replace it before I launch. Okay, a lot going on, but let's save. Let's rerun. Okay, let's place this. There we go. We now have our line. You can argue if you want the line above or below, but now I can launch the ball. Nice. Okay, so now that we've done that, we need to launch it in the correct direction because it's just going to launch, in the same direction every time. Okay, so let's go here and let's now calculate the angle. So I'm going to say the angle is equal to, and this is going to be calculate and then underscore angle. And I'm just going to pass to this my asterisk line, which is going to break the line into the two different, elements in the list and pass those as P1 and P2. So this will give me an angle in radians. Then I want to use that angle in radians to calculate a force, but the force is going to be based on the distance of the ball. So I'm going to say my force is equal to, and then this is going to be calculate force. Same thing, sorry, not calculate force, calculate distance. Same thing, I'm going to pass both the components of my line, and then I'm going to multiply this by 100 just so that we increase the amount of force. Now you can change this number if you want it to be less or more, but there you go. Now that we have the force, I want to break the force into the two individual components, and that's based on the angle of the line. So quickly, we'll do a little illustration here. So if my ball is here and my mouse is right here, then we have kind of a triangle that looks like this. This is a right triangle. This is going to be my total force, and then I need to break that force into the two components, so the x direction and the y. Now I know this angle theta, and since I know this and it's a right triangle, I can easily solve for y and x because I know both the force and the angle. So there's these great shortcuts, and just excuse me because I'm writing with my mouse here, but we have so, ka, and then I have this toa, okay? Now, O stands for opposite, H is hypotenuse, and then A is adjacent. And so if I want to calculate for X, for example, this is adjacent to the angle that I'm talking about, so I need to use cosine. So I take the cos of my theta. This is very, very difficult to do with the mouse. And then I multiply that by my force, and that gives me X. And then I do the same thing with sine for Y. So I take sine of theta multiplied by F, and then that gives me the force in the Y direction. All right, hopefully that makes sense. Quick trigonomic, what do you want to call that, lesson. So we'll say fx is equal to, and then I said we need to use cosine for this. So it's going to be math.sine, math.cosine of the angle multiplied by whatever this force is. I'm going to say fy is equal to math.sine of the angle multiplied by the force. And then here I can just pass my fx and fy, and now the ball should shoot off in that direction. Okay, so let's try this. And let's spawn a ball. And notice we shoot in that direction, and it goes quite fast. So we might want to reduce how much we're multiplying the force by, but let's try launching it like that. Okay, so let's reduce the force slightly. So rather than multiplying by 100, let's multiply by 50. We also could increase the mass of the ball if we want, and it would have the same effect, but this is fine for now. So if I go here, now I launch. Okay, that looks a bit better. Nice, then we're bouncing off of the floor. Let's launch in that direction. Looks great. All right, so now that we have that, the hard stuff is done. All we have to do is draw a few objects on the screen that we want to be able to actually hit, right? That's it. So let's do a function here. And let's say define, draw, or create underscore structure, okay? And let's take in here the space, the width, and the height. And then I will start designing kind of a few rectangles that we can interact with. So let's say rex is equal to, and let's place a few inside of here. Now I'm just going to copy some values that I have from the other screen. So let me have a look at these here. The first rectangle that I'm going to draw is going to be at 600, and then height minus 120. And then we're going to draw this at 40 and 200. And for the color here, I'm actually going to put my color up here. This is going to be brown. And this is going to be equal to 139, 69, 19, and 100. So our RGBA value. So I'm going to define my position, my size, the color of the rectangle, which is going to be brown, and then the mass of the rectangle, which is going to be 100. I did it slightly different for this because I didn't really care about the color of the mass, but here I want a color, and then we can adjust the mass, and you'll see that those objects behave differently and will move more if they have a lighter mass when they get hit by the ball, right? Okay, so there we go. That's the first rectangle that we want. Now let's copy this. The second rectangle that we want is going to be the exact same, except rather than 600, we're going to place it at 900. So we're going to have kind of two vertical rectangles here. That's what these two are. And then I want to draw a rectangle that goes over top of those vertical rectangles. And for that, we're going to need a position of 700 or 750, sorry. This is going to be height minus 240. And then we're going to have 340 as the width and 40 as the height. And then this is going to be brown again. And for the mass, it's going to be slightly more because this is thicker. So it's going to be 150. Okay, so we'll do the rest of the rectangles later. But for now, let's draw these out using a for loop. So I'm going to say for, and then this will be position, size, color, mass, and then in rex like that. Then we want to make a body. The body will be equal to PyMunk.body. This is not going to be static. We are then going to do the position. So body.position. Okay, this is going to be equal to the position. We're then going to make our shape. So I'm going to say shape is equal to, and then this will be PyMunk.poly.createBox. Perfect. We'll pass our body and our size. And then we'll say shape.color is equal to the color. Shape.mass is equal to mass. And then we'll say shape.elasticity, and we can set this equal to something like maybe 0.4. And we can say the shape.friction, and again, set this to whatever we want. Let's just go with 0.4. Okay, now we want to add this to our space. So I'm going to say space.add. I'm going to add the body, and I'm going to add the shape. And that should be all we need for this create structure function. If we want to add more structures or more rectangles, we'll just put them inside of here. We'll do that later. Okay, so let's now run this function. So let's say create, and then this is going to be underscore structure. Pass the space, width, and height. And I won't go through all of these different, values that I came up with, but you'll just see how they look on the screen, and then you can kind of adjust them and tweak them as you please. So let's run this and see we get this structure right here. Now, one thing I will show you is that if we want a nice outline for it, what we can do is pass a radius to our shape. So I can say radius is equal to 1. Now, this will add a curved edge if you make this really large, but it also adds a, kind of border for the shape. So here, when I make radius equal to 1, now you can see that we actually get a nice border. And if I say radius is equal to like 10, then we get a really thick border. Okay, so it rounds the edge slightly, as you can see, but it's also the thickness of the border for the shape. I don't want it to be quite that large, so let's maybe just go with 2, and that looks good to me. Okay, let's make a ball. Let's launch it at it, and nothing happened. Okay, there you go, something happened. So let's launch here, and I can actually take out the support, and they're going to fall, according to regular physics. All right, now that we have done that, we did our structure. Let's just handle doing that kind of jointed object that you saw before, kind of the swinging pendulum. And then I'll probably leave it at that because you guys can kind of add whatever you want to this, right? It's very simple from there to kind of add more objects, make more structures. You have the foundation done. So let's make a function here and let's say define, and let's go with create underscore pendulum. I have no idea how you spell that. Let's just say create swinging ball. There you go. That's more in my vocabulary. We'll take in the space. We'll take in the, actually, I don't even care about the width and the height. We'll just draw it at a static position here. All right, so here we're going to make a more advanced shape attached to our body, and it's going to be attached to a joint that's fixed to the screen. So we're going to have a body that's fixed to the screen. It's going to be our kind of rotation center. We're then going to have a joint between that and then our body that is not fixed that can actually move around the screen. But the body that's not fixed is going to be a more complex shape because we're going to have a line segment in combination with a circle. And so you'll see how we do more advanced polygons and shapes here in this example. Now I'm going to be reading from my other screen because I don't have all of this memorized. So if you see me looking over here, that's what I'm doing, just kind of referencing my code. So I'm going to say rotation underscore center underscore body. And this is going to be equal to a PyMunk body. And the body type is going to be PyMunk dot body dot and then static. Because this is not going to move. It's going to be that rotation axis, right? A rotation center body, as I say here. Then I need to set the position of this. So rotation center body is equal to, set this wherever you want, but I'm going to go with 300, 300. Okay, now that we have that, we want to make the actual swinging body. So I'm going to say body is equal to, and then PyMunk dot body. Okay, we need a position for this. So we're going to say the body dot, and then position is equal to, and then I have this set at 300, 300. Now, if you set this at the exact same position as the rotation center body, then when we draw the joint, you're not really going to see the joint. You'll just swing around the axis because of the fact they're together. However, if I were to change this slightly, so maybe I move the rotation body up and I make it like 270, now you'll actually see the joint between them. But this is showing you how you can make something swing when you have a joint. And again, if you put this in the exact same position, then our body is going to overlap with the rotation center body. And so it's going to look like we're just swinging around a static point as opposed to having the joint that's connecting the two, which you'll see in a minute. It's going to be better to illustrate when we actually have a visual here, but I just want to explain why I have the positions as I do. So here we're going to say line is equal to PyMunk dot, and then this will actually be segment. And we're going to pass to this the body, and then the two positions of the line that we want to draw relative to the body. So I'm going to say 0, 0, which means the first position of our line is going to be right in the middle of the body. And then the second position of my line is going to be 255 and 0. So X 255 and then 0 here. Okay. Then the next thing that we pass here is the thickness, which I'll go with 5. Now I'm going to make a circle. So I'm going to say circle is equal to PyMunk.circle body 0, 0. However, I think I need a radius for this as well. And actually, yeah, the radius comes first. So I'm going to go radius. Now, if I put this at 0, 0, again, this is relative to the body. So this means the circle will be directly in the center of the body. But I don't want that. I actually want it to be at the end of the line segment. So I'm going to pass this at 255. So now it'll be right at the end here of where this line segment is. Okay, so now we have our circle. Now we have our line. Now what we can do is set friction for both of these things. So I can say line dot friction is equal to 1, okay? And I can say circle dot friction is equal to 1. And I can also add elasticity as well as mass. So I'm going to say the line dot mass is equal to, let's go with like 8. And the circle dot mass will be equal to 30, okay? Then we are going to add elasticity for the circle. So I'm going to say circle dot elasticity is equal to 0.95, just so it bounces off of stuff, and then we can bounce our ball off of this circle. Okay, now that we've done that, we want to create our joint. So I'm going to say my rotation underscore center underscore and then joint is equal to, and then PyMunk dot, and this is going to be called a pin joint. There's some other types of joints and like springs and stuff that you can do, but pin joint's the one we're going to do. And then we have the two bodies that we want to connect. So we want to connect our body as well as our rotation center body. And then where do we want to connect on the two bodies relative to them? Well, 0, 0 and 0, 0. So what these two arguments say here is, okay, on the body, where do you want the joint to be connected? When I say 0, 0, we're going to connect it in the center of the body. And same thing here for the rotation center body. Now, if I were to change this slightly, I could make it so the joint was, say, attached to the very top of the body, or the left side of the body, or the right side of the body, or really anywhere on it that I want. So it's very flexible here with the joint. Okay, now that we have that, I'm going to say space.add, and I'm going to add a bunch of things here. I'm going to add my circle. I'm going to add my line. I'm going to add my body, and I'm going to add my rotation center body. Or sorry, not rotation center body, rotation center joint. Now, notice here that I don't add the rotation center body. Now, that's fine because there's no shape associated with the rotation center body. It's simply there so that we can use it in the joint. So for the joint, we have our body and our rotation center body. So you will actually end up seeing something on the screen for the static joint, but I don't want to draw the rotation center body onto the screen because we don't need to, all right? Kind of hard to explain it more than that. You can have a look at the PyMunk documentation, as I keep saying, if you want to learn more. For now, though, let's call this and let's see what happens. So let's say create swinging ball, and let's pass our space. And then, did I take a width and a height in here? No, no, just a space. Okay, so let's just take space. All right, let's run this, and let's see what we get. And we got an error. It says tuple object has no attribute underscore body. Okay, let me have a look here and see what the problem is. All right, I found the problem. I'm sure many of you already saw this. I forgot to put position here. So I said rotation center body is equal to a tuple, as opposed to saying rotation center body dot position is equal to that. So I changed that. Fingers crossed it should work now. Let's run the code. And there you go. now you can see we get what I was talking about. So I'm drawing the joint, right? So I have the 2 points of the joint, and that's why I didn't need to draw the rotation center body, because when I have the joint, I'm automatically going to get that. Now let's just launch something off of here, and obviously, the physics work as we expect. Okay, let's launch again. We can bounce them off of each other. And now let me show you what happens if I remove the distance or the displacement between the Y in the joint. So let's remove this, and let's change it now so the rotation center body is at the same position as the body. So now when I do this, so now you can see it just looks like we're swinging around this static point. You don't really see the joint. There's like a slight tiny bit of movement based on the way it's implemented, but it looks like we're just swinging on a static point, okay? So there you go. That is really all I wanted to show you. Now, I know in my example earlier I had some more objects, but I figured you guys can easily add that. You don't need to watch me for another 10 minutes. Just type in a bunch of lines of code, and all of the code that I wrote here will be available from the description. So if you want to, copy and paste it and edit it as you please. This is really cool. I'm planning on messing around with this module more and doing some more stuff in the future. If you guys want to see more PyMunk on this channel, please do leave a comment. Let me know. Tell me what type of simulations you want to see, what other videos you want to see on this channel. Always open to your feedback. If you guys enjoyed this, make sure to leave a like, subscribe to the channel, check out Programming Expert from the link in the description. And with that said, I will see you in another YouTube video.